In the course of your mathematical education, you will be introduced to several function families. You've already learned about the linear function family, and now we're beginning our study of the absolute value function family. Each function family has its own parent function, where the parent function is the simplest function within the function family whose graph shares the shape of all of the graphs within that family. So for the linear function family, the parent function was f of x equals x. The shape of that graph, that straight line graph, shares the shape of all linear graphs. All linear graphs are straight lines. Now we're looking at the parent function of the absolute value function family. The parent function of this function family is this function rule, this equation. F of x equals the absolute value of x. This is just like saying the equation is y equals the absolute value of x. We're just using function notation. To understand what the graph of the absolute value parent function looks like, and what every absolute value function graph looks like, we're going to find some ordered pairs in a table, and then we're going to graph them. What this means is I'm going to plug -3 into my function rule and see what my output is, see what my f of x or y value is. That'll give me an ordered pair. So if I plug -3 in for x, f of -3 is the absolute value of -3. The absolute value of -3, the distance -3 is from 0, is +3. Plugging -2 into my function rule, f of -2 is the absolute value of -2. The absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of +1 is +1. The distance 1 is from 0, 1. Absolute value of +2, 2. Absolute value of 3 is 3. Now each of these rows gives me an ordered pair that I can plot. So this tells me that the ordered pair -3, 3 exists on my graph of my parent function, on my graph of f of x equals the absolute value of x. -3, 3 is my first ordered pair. Then -2, 2, -1, 1, 0, 0, x equals 1, f of x equals 1, x equals 2, f of x or y equals 2, and then my final ordered pair from my table is 3 and 3. Now I have 7 ordered pairs plotted on my graph, and from this I can connect those points with straight lines and arrows to see the graph of my function. This is called the right branch of my absolute value parent function. And this, wish me luck, is my left branch. That was pretty good. I should have connected those ordered pairs with a straight line. And then I need arrows on either branch to indicate that this continues up and to the right, up and to the left. This is the graph of f of x equals the absolute value of x. This is the graph of the absolute value parent function. Now, since this is the parent function, this graph shares the shape of all absolute value graphs. All absolute value graphs share this general shape. We don't have a fancy word for this general shape. We just say the absolute value graphs are shaped like a V. Absolute value graphs are V-shaped. The left branch is this left side, the right branch is this right side, and the left branch has a slope of what? When x goes up by 1, what happens to y, or f of x? When x goes up by 1, y decreases by 1. X goes up by 1, f of x goes down by 1. So the left branch has a slope of -1. The right branch has a slope of x goes up by 1, y goes up by 1. X goes up by 1, f of x goes up by 1. +1. Those are characteristics of this particular graph of the absolute value parent function. Left branch slope of -1, right branch slope of +1. However, every absolute value graph will have similar characteristics, a left branch slope and a right branch slope. Let's look at another characteristic of the absolute value parent function, the vertex of this function. The vertex is the turning point of the graph. For f of x equals the absolute value of x, this is the vertex. This is where the slope of the graph goes from being negative to being positive. This point right here is the origin. For the absolute value parent function, the vertex is the point 0, 0. The vertex will always be an ordered pair like this. So there should be parentheses, x, comma, y, and parentheses. This, just like the left and right branch slopes, is a characteristic of this exact graph, the absolute value parent function. The vertex is 0, 0. But every absolute value function will have a vertex. It just will not necessarily be that ordered pair. It could be 4, 2 or -4, -6. It will have a coordinate, an ordered pair, an x and a y coordinate that is the vertex. Next characteristic of the absolute value parent function, the line of symmetry. The line of symmetry is a vertical line that divides the graph into two mirror image halves. Can you see where that would be? Vertical line dividing the graph into two mirror image halves is right here. It's a vertical line. I'm going to include arrows. And this being the line of symmetry means we have two mirror image halves. So the right branch is a mirror image of the left branch. Every point on the right branch has a mirror on the left branch and vice versa. So 3 units to the right, 3 units to the left. What's the equation of this line of symmetry? Well, it's a vertical line, so it will be of the form x equals. And then this particular vertical line has an equation x equals 0. X equals 0 is the line of symmetry for the absolute value parent function. And it won't necessarily be the exact line of symmetry of other absolute value functions. However, every absolute value function will have a line of symmetry. It just might be x equals 4 or x equals -7. Every absolute value function will have its own line of symmetry. Finally, the domain and range of the absolute value parent function. The domain is what? What possible x values have points on this graph? Well, as I'm moving to the right, every x value has a point on the graph because the arrow goes forever to the right, toward positive infinity. Similarly, every x value to the left, because the arrow goes to the left, has a point on the graph. The domain is my bold R, all real numbers. Every x value that you know has a point on the graph. The range, however, is not all real numbers. There are no points on the graph for y equals -1 or -3 or -6 or actually any negative y value. There is, however, a point on the graph for y is 0 and 1 and 2 and 3 and 4 and every bigger value. The range is y is greater than or equal to 0. Again, these are the characteristics of one specific absolute value function, the absolute value parent function. F of x, y, equals the absolute value of x. As you learn more about absolute value functions, each of those functions will have its own table, its own graph, its own vertex, its own line of symmetry, its own left and right branch slope, domain, and range. However, they will all share these common characteristics of being V-shaped, having a vertex, and having a line of symmetry. Domain and range is something we'll discuss a little later.